channel. In this session, we are going to discuss about source language issues. Now, this source language issues comes under runtime environment. First, I will give you the meaning of runtime environment. Remember, generally our programs are stored in the secondary memory. Whenever the program is ready for execution, and it must and should be moved to main memory. That is, the main memory is the runtime environment. That is the place where our programs are executed. Clear? That is called runtime environment. Under this, first topic is source language issues. In this, we will discuss different subtopics. Among them, the first one is activation tree. First, you need to know what is an activation tree. Simply, what is a program? A program consists of some set of procedures. A program consists of some set of procedures. Generally, each procedure declaration. Suppose we are defining a procedure, yes or no? The procedure definition consists of identifier. What is an identifier? Simply the name of the procedure along with statement. What is meant by statement? The body of the procedure. Now clear? A program is set of procedures. Each procedure definition consists of the name of the procedure along with the body of the procedure. Right now you know procedure. Now a procedure under execution. An execution of procedure is called activation. Remember the term. What is mean by activation? A procedure under execution is called activation of the procedure. Immediately, what is the lifetime of the activation? Lifetime of activation means simply the lifetime of activation is the sequence of steps that the procedure executes. For example, if the procedure consists of 10 steps, until completion of the 10 steps, the activation is under active stage. Once the procedure is completed, means the lifetime is ended. Simply, what is an activation? The procedure under execution is called activation. Okay. Now, consider two procedures. Assume A and B are two procedures. Remember, the procedures may be non-overlapping. Non-overlapping in the sense, and after completion of procedure A execution, move to procedure B. Simply, after activation of A, then we are moving to activation of B. Non-overlapping and nested is also possible. That means one procedure is executed inside another procedure. Now, recursive also is possible. Recursive means an activation of one procedure is called before ending of the same procedure. You know the normal program factorial, before end of the program we are calling n into factor of n minus 1. Exactly, this is the concept. That means if your program consists of different number of procedures, the procedures may be non-overlapping, may be nested, may be recursive, whatever it is. If a procedure under execution is called activation. Finally, you know the term activation. What is mean by activation tree? Activation tree is simply the way how the control enters and exit through the activation. So starting and ending, the flow of activation, the flow of execution of the procedure is referred by using activation tree. Now you understand? Activation tree is simply the way how the activation enters and leaves the procedure. In activation tree represented in the node format. Remember, each and every node represents activation of a procedure. For example, my program consists of 5 procedures. Each procedure execution is referred by using one node. 5 procedures in the sense, for execution of one procedure, one node. Then root node is fixed. Root node is activation of main. Each and every program generally consists of main. The main activation is referred in the root node. And one more point is, if a node for the procedure X, if a node for procedure X is a parent of node for procedure Y. Generally in the tree we have links, yes or no? Suppose if a node X is the parent for the procedure Y, then there is a flow from X to Y. That is, if X is the parent of Y, in the activation tree you have a flow from X to Y. So these are the properties of activation tree. Now I will explain this activation tree with one example. Suppose my example is starts with the main method. Suppose declare some one variable. Here I have one method read array of. Some simple quicksort example. Quicksort of, for example, 1 comma n. Okay, this is the main. Here first we are reading this method. After this quicksort, immediately go to quicksort algorithm. Quicksort of, assume some m comma n. In the quicksort, what is the first step? Generally partition. Partition of m comma n, or you can take m value as 1. That is your wish. Now quicksort of, suppose 1 comma I minus 1, quicksort of I plus 1 comma n. Here you take m or n, whatever it is. General, understand this one. Here I am applying the normal and the recursive also. For this procedure, for this program, how do I draw the activation tree? The root is main. The root is main. First the main calls the procedure read array. The main calls the procedure read array. Once the read array is completed, then it calls the procedure quicksort of. Suppose I will write in shortcut, it calls the procedure quicksort. Whenever the procedure is called, that means first to read array means the activation begins and completed. Whenever you are calling the quicksort, the activation begins, that is starts its execution. Immediately it calls this one. There, what is the first method? Partition. For example, partition of some value. Partition. After completion of the partition, then we are moving to this one. For example, quicksort of 1 comma. Assume I is equal to some partition gives the I value as 5. We can take anything. 4. Now this one recursively called. Again it calls the quicksort method. Again what is the first step? Again it calls the first step. Partition of some 1 comma n. Suppose it returns, assume n value is equal to 3. Again it calls quicksort of 1 comma 2. Now for example, this is repeated multiple number of times. At one stage, if it is completed, we are moving to this one. Like this, quick sort of some 4 comma 4. For example, here quick sort of some 6 comma n and so on. Now you understand? So I think you know how to draw a tree recursively. Sir, I have confusion. No problem. Simply, what is the flow of this activation tree? Follow pre-order depth first traversal. Pre-order depth first traversal. We are getting the flow of the activation tree. Here it starts from the root. Pre-order depth first traversal from the root. Now what is the first one? This is pre-order means root to left child and then right child. First root is visited, followed by left child, and then here. So this is completed. This is the root, this is the left child, and this is the right one. Again for this one, this is the root, this is the left one, and so on. I think you got it. This is activation tree. Activation tree. Clear? Now, my second point is control stack. My second point is control stack. It is also called as a runtime stack. What is the purpose? This control stack keeps track of the procedures that such that their executions are not completed. For example, you have set of procedures. The procedures whose execution is not completed. Such procedures are referred by using control stack. If it is completed means no need to consider. Clear? Control stack keeps tracks of the procedures that are not completed their execution. Now, whenever a procedure starts its execution, the procedure name, remember, the procedure name is pushed into the stack. So first you understand what is the purpose, to keep track of the procedures that execution not completed. Whenever a procedure is called, the name of the procedure is pushed into the stack. Meaning is the activation of the procedure begins. After completion, the procedure is popped from the stack. That means the activation ends. The activation ends. This is the purpose of control stack. This is the purpose of control stack. Now we will discuss the most important thing, activation record. Most important thing, activation record. What is mean by this activation record? Simply, what is the purpose of control stack? The control stack keeps track of the procedures whose execution is not completed. Now, the procedure name is pushed into the stack whenever we are calling the procedure, and after completion the procedure is popped out from the stack. Yes or no? Yes. Now, during the execution, the information that is needed. So, during execution, I did some information. The information needed by the execution of the procedure is managed by using activation record. Clear the point? Now simply activation record supplies all the information that is needed for execution. Now whenever a procedure is called, the activation record of the procedure is pushed into the stack. Whenever a procedure is called, the activation record of the procedure is pushed into the stack. After completion of the procedure, it return back to the caller. Yes or no? If I am calling, whenever I call, the activation record is pushed. After completion, it return back. Once it return back in the sense, the activation record from the stack is popped. Clear the point? Whenever calling, activation record is pushed to the stack. After completion, activation record is popped from the stack. Now, for this activation record, I will give you one example. For example, main, just to understand, some set of statements, I have some procedure. Now, A of some set of statements, I have some procedure. Understand this one. Before calling the procedure A, first the activation record for main is created. That means my execution starts from main. Before calling A, the activation record for main is created and it is pushed into the stack. After that, the activation record for A is created and pushed into the stack. Now move to this one. Sequence. Before calling B, the activation record for both main and A are created and are available in the stack. Now the activation record for B is created and so on. I think you observe. Now consider one example. You already know the quicksort example. So what is quicksort example? Main. So first one method, read array of is one method. Now quicksort of m comma n. Now coming to quicksort algorithm, quicksort of m comma n. Here first I am performing some partition operation. Partition of m comma n. Now quicksort of m comma I minus 1. Quicksort of I plus 1 comma n. So this is my procedure. Now how to write the activation record? First, main is pushed into the stack. That means the activation record of main is created and it is pushed to the stack immediately. Next to read array. Read array is pushed into the stack. The activation record for read array is pushed to the stack. Now read array is completed. Whenever the procedure is completed, the activation record is popped. That means the read array is popped out from the stack. What is the next one? Quicksort. You are calling the quicksort function. Whenever you are calling the quicksort procedure, what it calls? It calls partition. Main quicksort. It calls partition. Understand? Okay. After completion of the partition is popped out from the stack. The partition is completed, that is, it is popped out of the stack. Again it calls quicksort of suppose m comma I minus 1. Now whenever you are calling this one, again it calls this partition function. Once the partition is completed, that is popped out. You understand? Activation record. Simply whenever you are calling the procedure, the activation record is pushed into the stack. Once that procedure is completed, the activation record is popped out of the stack. This is an example. Finally, how the activation record looks like. Here I said the information needed for execution of a procedure. Now what are the informations that are available? What is the structure of activation record? So the activation record consists of the first one, local variables. Local variables, simply the variables that hold the local data during the operation. So during the procedure execution, suppose a procedure is executed, during the procedure execution, to hold the local data, that is the data belongs to the procedure, the data is stored under local variables. Next, temporary variables. Temporary variables means simply hold the temporary data that arise during evaluation of an expression. Suppose I given one expression to you. During evaluation of an expression, if you need any variables, then the temporary variables are created. Now, next one is mission status. Mission status means before calling the procedure, it stores the status of the mission. Mission status means simply to hold the status of the mission before calling the procedure. Before calling the procedure. Next one is access link. This access link is optional. What it do? It holds the non-local data of another activation record. What is this one? Access link. Simply it refers the non-local data of another activation record. Right? That means right now I am in this activation record. If I want data of any other activation record, that reference is provided under this access link. Next one, control link. Control link. This is also optional. Simply control link points to, that is refers to or points to the caller. That is the function, the procedure who calls this one. For that caller, that control link points. For that caller, the control link points. Return values. Return value means whenever I calling some procedure, suppose I am procedure, whenever I call someone, after completion it returns some value. Yes or no? The returned values are stored here. Return values are stored here. And finally, actual parameters. Actual parameters in the sense the original parameters that are passed from calling procedure to called procedure. Now this is the information that the activation record maintains. Now I think everyone clearly understand what is an activation record. When the activation record is pushed to the stack, when it is popped from the stack, what is the advantage of this activation record? Clear? This is activation record. Now final point is, this is the runtime environment. That means my static text of the program is dynamically copied into runtime. Here subdivision of runtime storage. That is, my runtime storage is subdivided into 4 parts. My runtime storage is subdivided into 4 parts. The first part is code area, also called as target code area. Simply the place where the code of the program is loaded. The code of the program is loaded. Next one, static data area. Simply in any program that consists of static information. What is mean by static? Common, shared variables, shared memory. That shared information is available in the program. That entire shared information is stored under static data area. Now stack. So you know that one, stack is used to store the activation records, to whenever function is called and completed to pop out. Simply stack is used to store the automatic data objects. And the last one is heap. Heap is dynamic memory allocation. That is, heap is used to store the dynamic data objects. Generally, this is called low address space. This is high address space. Now, a heap moves to high to low, stack moves to low to high. These are the four divisions of runtime storage area. Now finally, this is source language issue. The source language issue, what it cover? Activation tree, control stack, activation record, and then subdivision of runtime storage. Okay. In the next session, we will discuss different storage allocation strategies. Thank you.